All right, let's get started with doing variables in C++. So, first things first, let's open up a folder. We'll call this one, let's just make a new one here. Call it whatever you want. I'm just going to call it variables. Select. All right, so let's add our standard main.cpp. And then, again, going off of previous tutorials, let's make a very simple C++ program. We'll use our standard include IOStream because we're going to see out something to the console, and then our super simple int main initial function here. So call int main, and then we'll return 0. Okay, so now we can get started. So first things first, when we create a variable, you have to tell the compiler what kind of data type it is, and you do that first. So if we were going to create a variable called first, okay, or number or whatever, we're going to use first because I'm going to also have a second one later. It doesn't know what this is, okay, so we have to put it in front. So this variable is going to hold an int, an integer, okay, and you can see VS Code has already cleared up that error here, okay, and again, C++, we end it with a semicolon. So this value first right here is, the compiler is going to know this is going to be an int. However, when it does this, we haven't assigned anything to it. So with C++, there's garbage in this. As soon as we initialize this, all it does is just assign a memory address to this variable. It hasn't cleared it, hasn't assigned anything to it. And if we want to see what was parked in there, we can just do a standard cout. So, oops, sorry. And then we'll just go first. Okay. So if we compile this, let's go ahead and grab our terminal. Where is it? There it is. New terminal. Okay. I'm going to hide this so we get a little more room. Let's go clang. Oops. So I'm going to use the clang compiler. I'm going to feed it our main CPP. And then our output, I'm going to just create a little app called app.exe. Hit enter. Should work just fine. All right. So here's our app that was compiled. Drag it down here. Now I'm going to hide this again just so we have a little more room. So when I hit enter down here, you're going to see this is the garbage I was talking about that was at that address. Okay, when the compiler built our program and created a variable called first that was an integer, this was the value that was stored in memory at that location the last time it was used. Okay, this is going to be different for everybody's computer. So obviously this is useless to us. We need to assign a variable to this, or a value. So we can do this a couple different ways. You can simply just go equals 5, okay, where we do it all in one line. You can also create the variable first, and then you can then assign to it later. So first rst equals 5. Okay, you can do it just like this, fine. This is inefficient. Okay, now we do this, but if you're trying to write high performance code, even doing this on one line is actually not the most recommended way. Now, it turns out there is a number of versions of C++. This, I think it was first created in 1979. If we bring up a little browser here, C++ versions, yeah, 1979. Gosh, go away. There was a small cleanup done in 98, okay? But the big changes happened in 2011. So these are the names of the various versions of C++. So C++ 11, every few years they come out with another one. Here's 14, another big one in 17 and 20, and then here's all the current stuff. So this is the version I use. And we'll get into that in a sec. So the reason I brought that up is one of the new additions to C++ was the ability to initialize a variable like this, but much more efficient. So right now, when the compiler compiles this code, it creates the number 5, which it knows is an int, and then it copies it into this variable called first. So we can do that in one step where the variable is initialized and assigned the value in one shot. And it's written like this. We'll call it second. And it's put in brackets. Okay? So this is the current recommended way of doing this. It's much more efficient, it's faster. But if you're used to writing stuff like this, which is me, this looks a little funny. But this is super powerful. We're going to use this a lot later. And then if we were going to do something with this, let's make it a 6. Let's say, we'll say here, 5 plus 6 equals first plus second. Okay. Just make sure I didn't do any typos. All right, cool. Let's compile this. So another terminal. All right, there it is. So I can drag this down here, hit enter, and sure enough, there it is. Now, I want to show you one other thing, and some of you are going to run in. You're going to run into this. I'm on Windows right here. The default compiler that is called when I hit Clang, the default version it's expecting is late enough that this was included. Okay, I think on this computer this was added in 2014, so this would be the C++ 14 version. I think on my Mac for some reason this goes all the way back to 11, but I want to show you where you can explicitly call this out. So if I go back to my command line here, I can call this out like this: clang plus plus, and then I'm going to go dash standard, so std equals C++. Now this is where you put the year. So for example, if I put 98 here, and then I tried to compile this, okay, using this this is called a list initializer. If I did this here, let's go main.cpp out app.exe. Watch this. Yikes. Lots and lots and lots of errors. It freaked out because it has no idea what this is. Okay, so let's clear this. If I do the same thing, but instead of doing 98, let's pick a newer version, 14. Okay, hit enter, boom, compiles it just fine. So when you guys compile code, I want to make sure that you're using at least a newer version. It doesn't hurt to use the current one. If I go, this is what I use, and it works just fine. Okay, so just as a heads up, if you're getting weird errors, you might have to explicitly call out the version of C++.